Welcome to YQ Academy Exceptions and Exception Handling Java Interview Questions and Answers. 1. Explain how try catch block works. The code within the try block is executed. If an exception occurs within the try block, the remaining code within the try block is skipped, and the control transfers to the catch block. The catch block specifies the type of exception it can handle using the exception type. When an exception of that type is thrown, the catch block is executed. The exception object is assigned to the exception variable, which can be used within the catch block to obtain information about the exception. Inside the catch block, you write the code to handle the exception. This can include error logging, displaying error messages, or taking appropriate actions to recover from the exception. Basic syntax of the try catch block. 2. Explain importance of finally block in Java. 1. Cleanup operations. The finally block is commonly used to perform cleanup operations such as releasing resources, closing connections, or freeing up system resources. For example, if you have opened a file or established a database connection within the try block, the finally block ensures that the file is closed or the connection is properly terminated, regardless of whether an exception occurs or not. 2. Guaranteed execution. The code inside the finally block is guaranteed to be executed, regardless of whether an exception is thrown or caught. It ensures that certain critical actions are performed, regardless of the control flow or the occurrence of exceptions. This is important for maintaining the integrity and stability of the program. 3. Exception propagation. If an exception is thrown within the try block and not caught by any matching catch block, the finally block will still be executed before propagating the exception further up the call stack. This allows you to perform necessary cleanup operations before the exception is handled or propagated, preventing resource leaks or other undesirable side effects. 4. Error recovery. The finally block provides an opportunity to perform error recovery operations before terminating the program or taking further actions. You can use the finally block to log errors, display error messages, or perform any necessary recovery steps to bring the program to a stable state. 5. Control flow management. The finally block can be used to modify the control flow of the program by using the return statement or throwing exceptions from within the finally block. However, it's generally recommended to use the finally block for cleanup purposes rather than modifying the control flow, as it can make the code harder to understand and maintain. 3. What are checked exceptions? In Java, checked exceptions are a type of exception that must be explicitly declared or handled by the calling code. These exceptions are checked at compile time, meaning the compiler enforces the requirement for the calling code to handle or declare these exceptions. Checked exceptions typically represent exceptional conditions that can occur during the execution of a program, such as file I/O errors, network errors, or database errors. Examples of checked exceptions in Java include IR exception, SCL exception, and class-not found exception. 4. What are unchecked exceptions in Java? In Java, unchecked exceptions, also known as runtime exceptions, are exceptions that do not need to be explicitly declared or handled by the calling code. Unlike checked exceptions, unchecked exceptions are not checked at compile time, and the compiler does not enforce the requirement for the calling code to handle or declare these exceptions. Unchecked exceptions are typically caused by programming errors or exceptional conditions that may occur during the execution of a program. These exceptions are unexpected and often indicate a fault in the code or a violation of the program's logical or contractual assumptions. Examples of unchecked exceptions in Java include null pointer exception, array index out of bound exception, and illegal argument exception. 5. Explain differences between checked and unchecked exceptions in Java. 1. Declaration requirement. Checked exceptions must be explicitly declared in the method signature using the throws keyword or handled using a tree catch block. No declaration requirement. Unchecked exceptions do not need to be declared explicitly in the method signature or handled by the calling code. 2. Compile time checking. The compiler enforces the requirement for the calling code to handle or declare checked exceptions. It ensures that the exceptions are properly handled or propagated. Runtime checking. Unchecked exceptions are not checked at compile time, allowing them to be thrown and caught without the need for explicit handling. 3. Expected exceptions. Checked exceptions typically represent expected exceptional conditions that can occur during the execution of a program, such as file I/O errors or database errors. Programming errors or unexpected conditions. Unchecked exceptions are typically caused by programming errors or unexpected exceptional conditions that may occur during the execution of a program. 4. Forced exception handling. The calling code must either handle the checked exception using a tree catch block or declare it in its own method signature. Optional exception handling. The calling code is not required to handle or catch unchecked exceptions. They can be caught and handled if desired, but it is not mandatory. 5. Propagation control. Checked exceptions propagate up the call stack until they are caught and handled or until they reach the top-level default exception handler. Propagation control. Unchecked exceptions propagate up the call stack until they are caught and handled or until they reach the top-level default exception handler. 6. Examples: IR exception, SCL exception, class not found exception. Examples: null pointer exception, array index out of bounds exception, illegal argument exception. This is the end of our Java interview questions. We hope you enjoyed learning with YQ Academy. Until another time, goodbye.